Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1514, which is path with maximum probability. Let's see the problem statement. You are given an undirected weighted graph of n nodes, 0 indexed and represented by an edge list where each element of edge will be a, b, where there is one undirected edge connecting a and b, and with probability of success of traveling, that is success probability of I, and given two nodes start and end, find the path with the maximum probability of success to go from start to end and return its success probability. If there is no path from start to end, return 0. Your answer will be accepted if it differs from the correct answer by 1 by 10 to the power 5. Okay, and the constants are the number of nodes will be up to 10 to the power 4. Start end will be less than n, start will not be equal to n, and AB will be less than n, A not equal to B, and the length of edges and success probability will be the same, and each element of success probability will be 0 to 1. That means it will be double value, which is given the vector of double, and there is at most one edge between every two nodes. Okay, so let me discuss the algorithm with you. So first we need to convert the given edges and probability into a, like we need to store that if for each vertex we need to know that all the other vertex which are connected to it by any edges, and also along with their success rate or success probability to traverse. Okay, we will need to store that, and we will use unordered map to store that. And second, we will use a priority queue because we need to every time we need the highest probability value like node to traverse. Like for example, if we are standing at 0, we need to store the probability of 0 also along with, and the probability will be the probability of from start to coming to the current node, and the like priority queue will give us the maximum priority value or maximum probability value in store the vertex, and we will check the vertex, the current vertex is equal to the end node or not. If it is end node, then we will simply return the probability value which is assigned to it, and otherwise we need to calculate the probability value for each of the neighbor of the current node, and along with the neighbor we will store that probability value in the priority queue. That's how we will do it. Okay, so first we need an unordered map. The key will be integer because the key will be the vertex number, and the value will be a vector of pair, because vector because there could be multiple neighbor of each like vertex, and pair because we need to store the two things, which is the neighbor value index, like neighbor vertex value, and the probability which will be double. So we will store that in a pair int the vertex number, and the probability will be double. So this will be the map, and we'll traverse for int I equal to 0, I less than edges dot size I plus plus. Now the u, let's say u is the edges I 0, the v will be edges I 1, and the success rate is will be the success prob I. Okay, and the s will be double, not int. These are the three things, and first we will add map of u. It will give us the vector, and we'll push back the pair. The first one will be the v, and second one will be the success rate s, and we'll do that for both of them, u and v. For u, the neighbor is v, and for v, the neighbor is u. That's it. Now we have stored the graph in a unordered map. Now we need the priority queue. Priority queue. So we need to prioritize that the success rate based on the success rate. So the priority queue will be pair because we need two things. One is the current node and the along with the success rate to reach to the node from the start. So the first one will be the double value because it will be the success rate, and second one is the int. That will be our priority. And first we will add in the pq.push because we already given the start node. So we know the success rate from go start node to start node will be 1, and we'll add the start node in the priority queue. It will be initial state. Second, we need a visited because in priority queue there could be multiple instances of the same. Let's say, for example, the probability of 2 could be 0.2 and also 0.25. So there could be like two vertices with the value of 2, but the probability will be different, like 0.2 and 0.25. So we need to check that if the current node is already visited or not. So we'll also need a vector of Boolean type, and the size will be n because there could be up to n vertices. And initially, by default the Boolean value is false, so we do not need to specify the false again. So we will loop over until pq dot size existed, like if at least one element is present in the priority queue. First we need the top element, so pq dot top, and we'll pop that. Now first we need to check if the node is already visited or not. So first we will check if visited of the node is at the second position. So it dot second is already visited or not. If it is already visited, just then we do not need to perform anything. So continue, and otherwise take the same and mark it as visited. To mark it visited, just make it true. So it is already visited. Second, we need to check if the current node is all the end node or not. If the it dot second, which is the current node, is equal to end, what is the name, end node or not. If it is end node, directly we can return the value, assigned value or assigned success value, which is it dot first. Okay. Now if it is not like the end node, then we need to store all the neighbors of it which are not already visited. So we will loop over the all the neighbors. Let's say neighbor is element, or element, let's say element, and the neighbors are, we can find it in map of the current index, which is it dot second. We will find it all neighbors in the map, and we need to take the neighbor value is element. The neighbor value is the first one. So element dot first will be the neighbor value, and the success rate will be real dot second. This success rate is the success rate from going the current node to that v or that neighbor. This is the that success rate. Okay, second we got the second. So we need to check if not visited the v, then we need to push it. So pq dot push, and what will be the first value is the success rate for to go to v from the starting node. To get that, first we know to the success rate from start to the current node is it dot first, and we will multiply that with s because s is the success rate from the current node to v. So that will be, after multiplying, that will be the success rate from the start node to V, and we will also add the V as the second. So this will be the thing. And after the while loop, we need to return. If we do not find any path from that node, start node to end node, then we need to return 0. So let's see will it work or not. It is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities of this algorithm. So the time complexity for this first loop will be big of E, where is the number of edges. Okay. Second, this while loop will run until the PQ is empty. I will tell you later what is the time constant for this while loop. First, see what is the time constant for this inner for loop, because in worst case there could be like it is this for loop is running for all the neighbors of current node. In worst case, the neighbor could be n minus 1 neighbors. If the number of vertices is n, then maximum neighbors could be n minus 1 of the current neighbor. So this follow could run up to n minus 1 time, or big of we can say v time. And to push one element, it will take big of v time, log v time, big of log v time, where v is the all the number of elements in the priority queue. So it will take log v time, and we are performing log v time. So overall time complexity for this for loop will be big of v log v. And in priority queue, let's see what will be the maximum size of the priority queue. The maximum size could be, let's say in most case, every node has like one edge to every other node. Then the maximum like size of this priority queue could be big of n square, where n is the number of vertices. But we will not perform this operation if the node is already visited. So we will only performing this operation for unvisited nodes, and maximum unvisited nodes could be like n, like what is the total number of edges like vertices, that will be the maximum unvisited vertices. So this while loop or this overall while loop time complexity will be big of v square log v square, because this could be v times, and this is already I told you this is v log v times. So overall time complexity for this while loop will be big of v square log v, and for this is big of e, it will be also in terms of v, it will be also in worst case big of v square. So the overall time complexity will be v square log v, where v is the total number of nodes or total number of vertices. And let's say like what will be the space complexity to store all the edges. This is maximum big of e, like take space complexity, or you can say also v square, maximum every edge in host case, like each vertices connected with every other vertices. So the space complexity to store this will be big of v square. And also I already told you the maximum possible size of this priority queue will also be big of v square. And we are also storing like visited array, which is the size of n. N is the number of vertices, so it is also taking big of v space complexity. So overall space complexity will be big of v square, and the time complexity will be v square log v. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.